Hello. Hey guys. Can you guys hear me?
Yes.
Okay, so we shall wait for 5 minutes and we shall start at 7:05. Let's wait for others to join in. Like someone is going a lot. Yeah. Uh, so hi guys. Let's get started for today. Can you guys hear me? Put something in the chat so that I can know that you guys can hear me.
Yes.
So great. Can you see my screen? Put a yes in the comment if you can see my screen. Okay. Thank you, Ekji. Okay. How many of you are present here? Because I don't see many responses. So how many of you are active?
I mean,
Mhm. Thanks, Ekji. Maybe you can put your name in there. That would be easy for us. Ashok. Thanks, Ashok. Okay. So we can get started. Uh, So today, this is our first session on deep learning fundamentals. We'll be learning throughout this course, we'll be learning starting from basic machine learning, a good overview of how transformer model, machine learning model, neural network models work, and then going deeper into all the generative AI models that are there out there in the market. We'll also have a hands-on so that we have a good understanding of what we are studying in the theory. We'll be sharing material as and when required, right? And if you have any doubts, let's just set the flow of our interaction, our session, how the session will go. What I want all of you to be a little active in the session, right? Respond to the question. If you have any questions, please stop me and ask wherever you have any sort of doubt. It would be beneficial not only for you, but all of us to get a better clarity of the topic that we are discussing for that point of time, right? Put a yes in the comment, or maybe you can speak up. Okay, thanks Ashok. Thanks Shanav. Okay, so I see there are only 3 participants out of 5, 6 candidates that we have in here. Also, I would love to know before we get started, I would also like brief about myself, and then would love to know about you guys as well, because that is going to help us um, take things further, will help me understand what your background is, what level of explanation you would need for a better understanding of the topic. And definitely, what I would want is whatever the topic that we are discussing, before the session ends, you have understanding of the concept that we were discussing for that day, right? Maybe not everything. You will get a number of resources out there, which I'll be also guiding you with. But you will have a broader overview of what to read and what not to read, what would be good to begin with, right? Please do stop me if you have any sort of doubt at any point of time. Okay. So a brief about me. I am Ankit. You can call me by name, and if you guys you want to. And I am a graduate from Delhi University. I have BTech in electronics. Post, I have also completed an analytics program from IIM Indore. And brief about my work is I'm currently based in Bangalore, working in a startup called Lego AI. I'm currently working on the pipeline, which is completely AI-based pipeline, end to end, starting from data input, which is enterprise level data, and we are working towards making the conversational response seamless in a natural language, and that will come out of the enterprise structured data, right? That's a pretty complex thing that we are trying to work with, and we do have a decent enough, like good accuracy as well. Before that, I was also working as a data analyst with Amazon. I was there for over 2.5 to 3 years, and I've been working for a year in the current role. And I'll be taking your session throughout, and I'll be guiding you through your journey. And I would definitely want you to enjoy the journey. And once we are done with the course, you will have an understanding, I would say, pretty good understanding of what is happening out there in the market and what is needed for you to get started with. Um, Also, whatever the efforts that I'll be trying to put from my end, I'll try my best. But if you guys do not replicate similar sort of efforts, that would be challenging to grab things. So try to grab things, whatever the topic that we are discussing on the same day, clear the doubt as soon as possible, so that there are a lot many things that you can come up with, you can learn throughout the journey, right? And that was brief about myself. And maybe you guys can briefly tell me about yourself. Where are you based in right now? Are you a working professional or a student? If you are a working professional, what is your domain that you are working in? If you are a student, what is the major that you are having? Okay. Raki is Delhi based. Okay. Working in IT. Okay. Thanks, Raki. What exactly in IT? What is your job profile look like? And where do you see you will be able to use AI and generative AI in your work profile? For data analyst, ML, and artificial intelligence. Okay. Noida, QA. Thanks, Amshir. We have two from Delhi or Delhi NCR. Don't get offended when I count Noida with Delhi. Huh? Okay, KG said working in IT as architect towards microservice world. Plan to explore career in generative. I am from Bangalore. Oh, great. Uh, nice. Mumbai. Okay. Telecom network analytics domain. Okay. That's good to hear. Okay, so we have people from all over the India, not all over the India, but all three directions as of now. Do we have more? There are only four people, is it? And also, do let me know what language you guys are comfortable with. So I'll be majority of my discussion is going to be in English, but if sometimes required, I might flow into Hindi as well. But don't worry, I'll be explaining the same stuff in English as well. So whenever you feel that something is you are not able to grab, just let me know. We'll definitely switch to English right then and there. Okay, okay, KJ is comfortable. Shravan is from Hyderabad, working on ML Python, looking forward to upskill in Gen AI. Okay. So, Shravan, what kind of machine learning model you are working with? Maybe you want to uh, unmute yourself and give us briefly what kind of challenge that you face, how you learn, so that other, if those who are not into machine learning or Python field, they are able to understand how it should go.
Yeah, hi Ankit. Yeah, this
Hi,
is
Shravan. Yeah.
yeah. So basically, like from the past 1 year, I'm working in Python, but like previously, I worked on some machine learning use cases related to banking, BFS related, more particularly
Mhm.
on this asset and wealth management side. So kind of
Mhm.
mostly into clustering. Like unsupervised use cases algorithm using clustering algorithms and also some classification models.
Mhm.
So
Okay.
yeah,
Yeah. So I believe all these machine learning model that you were using, they were all, I won't say traditional, but yeah. So they were all
yeah,
traditional machine
yeah.
learning
The
model that has been there out like for over a
correct,
decade now, right?
correct. Yes,
You were
yes,
doing building a model, doing hyperparameter tuning, trying to get the best possible prediction out of your model, right?
yes. Exactly. Yeah.
Yeah. So how many of you understood what Shravan just said? He mentioned something about supervised learning, something about classification. How many of you are familiar with these terms?
Yeah, I understood what you told.
Okay, Shamsher is comfortable. Ashok is also comfortable. So how many of you understand Python, data analytics, understand data basically, and machine learning, so that we can have a understanding of fair idea? Okay. Ashok has a fair idea. Is there anyone? Okay, Ra- Raki says Python and ML she is comfortable with. Machine learning is high level, rest all I am good. Okay, I have a fair idea of data science. Okay, so I think majority of us are comfortable with machine learning tools, right? So that should be okay, but we do have people also for which machine learning is a little on the higher level side. But I think, uh, can we get the recording? Yes, you guys will get the recordings as well. Don't worry about that. But for all, let's just revise, let's just discuss uh, a brief about how machine learning, so that we can flow into the journey from how traditional machine learning model, all those supervised and supervised learning model that was just mentioned by Shravan. From there, how we switched and what are the stages in which we upgraded or switched uh, to generative AI. Generative AI is a machine learning model, but it is more sophisticated, more robust, right? Okay, because in some time I'll be having a client call. Okay, Raki. So for how many of you Saturday is a working day? Because I know it's a pain when you work on your weekends. For Ashok, it's a holiday. Lucky Ashok. It's rotational basis. Okay. I understand, Raki. Even I use worked sometimes over the weekends as well. I was working today as well. So yeah, uh, got it, got it. No problem. Uh, okay. No problem. You can have all the recordings on the portal itself. Once the session is over, the recording should be there within some time. Okay. Yeah, sure. So what to expect from today's session? The discussion that I had planned for today, it was how we are going to move from traditional machine learning model and how the machine learning models were evolving, not going deeper into the machine learning models, but a broader understanding of how things are working. So that if I see there was someone for which machine learning was a little on the higher side, so that they are able to understand the logics behind, maybe not nitty gritty inside the logics, but on a broader level, they have an idea of how things are flowing, how things has evolved over the period of time, right? So we'll be moving towards that. We'll have a briefly understanding how machine learning models were traditionally there and how they have evolved, and what are some types of machine learning model. From machine learning model, how we have evolved to the neural network and how neural network works. There are some key terminologies within neural networks. Some of you might already be aware of, some of you might not be aware of. There might be something new for some of you. So that would be good for all of us. And then there are a couple of type of neural network. This is on a broader level, right? So we will be discussing that as well. And then to work with neural networks, we have some framework. Just like for handling data, you have libraries available for you like pandas, right? You have NumPy for numerical operations. You have Seaborn, you have Matplotlib. These are some of the common libraries for machine learning that we use. Similarly, for neural networks, we do have some of the frameworks which helps us easily or faster building of those neural networks and with full control. Yeah, right. And then we will also be discussing a concept for transfer learning. What is transfer learning? We'll be discussing that in detail. What are some of the use cases for transfer learning and how transfer learning has been a game-changing event throughout, I would say, last decade since machine learning model has evolved to a generative AI model. It's all because of transfer learning that we have, right? And then we'll be briefly touching on the transformers if time permits us. Else we'll be discussing the transformers model and everything in detail in our next session, that is tomorrow, right? So this is the list of topic that I have planned for today. Some of you might already be aware of some of these topics. So please be patient with me. For those who do not, or I would say have a less idea of these topics, we can have a good discussion, and maybe those who are aware, they can add into the discussion so that the others are able to understand the topic, the concept better, right? So have I made things clear to you guys? What are we going to do in today's session? Put a yes in the chat, and also keep interacting so that I know you guys are not you guys are there with me, and I'm not just speaking with my screen. Okay, thanks, Kalpana. I think you just joined. So maybe Kalpana, you would want to share from where you are. What is your domain if you are a working professional? What is your domain that you are working in if you are a student? Uh, what is the major that you are having? And most importantly, is it a working weekend for you or you have a holiday? Maybe you can turn off, like unmute yourself and speak up.
Yeah, so I'm Kalpana. I'm working and I'm working the SharePoint and the Power platform.
Okay,
So my
good to
more
know.
interest in the AI and the Python right now because in the Power Platform SharePoint there is less scope right
Sorry,
now.
Kalpana,
So
we are losing you. We can hardly hear you.
yeah, okay. Now you can listen to
Yeah.
me.
Yes, I can.
Yes. So what I'm saying that I'm working in the SharePoint and the Power Platform, and I in the last company I was working in the C# as well. So I have a very good knowledge on the OOPS concept and the coding as well.
Mm-hmm.
So right now, since there is you can say so I'm interested in the AI and the Python. So I just joined this course so that I can brush up my skills and go to
Mm-hmm.
another department.
Yeah, that's that's what we all expect when we are all upskilling ourselves, so that the new thing that is coming up, we can how we can use it or how we can leverage this in our current role or maybe switch to a new role. That's
Right.
definitely we all are
Yeah.
on the same page then. Yeah.
Yeah, because in a power platform as well, or you can say the power BI, there we can use a Python as well as the machine
Mm-hmm.
learning as well. So,
Yeah.
I think there is rare any field, or you can say the technology where we cannot fit them. So, it's, I guess,
Mm-hmm. Yeah,
the
understood.
requirement.
Yeah, correct.
Yeah.
No worries. We'll get started with our today's session. Also, Kalpana, if you can highlight how comfortable with you are with the machine learning concepts.
Yeah, it's actually if you are going through, let's see how can I grab because I
Okay.
go through the videos, so it's not new to me. But let's see
Okay.
what's new
Okay,
to
great.
come up. Okay,
Great.
yeah,
Sure.
thanks.
Yeah.
Ankit, Ankit,
Yeah,
I have a
please.
question.
Yeah, please, Samshid.
So, after a weekend classes, are you going to give us an assignment so, we can practice,
Mm,
on that and
y-
submit to you so you can see that how we
Yes, we'll
are
be having after the session, we'll be having quizzes as well as, and if needed, we'll be having the assignment as well. Like today's discussion, it is a like a basic or I would say introductory overview of what we are going to do, what is our agenda throughout our session, right? How
Mhm.
we are planning to take it up. Once we have understanding of that, or we have a discussion on the basics, how things are flowing. Once we have the basic build up, then we will be proceeding further to some advanced topics, and there will be having some assignments. So not all the session will have the assignments, but yes, there will be session where you will have the assignment and you will be doing it and submitting it within the timeline.
Okay, so thank you.
Yeah, great. Do we have more questions? We can take the questions now and then we can proceed. Okay, I'll take the silence as we do not have any more questions as of now. Okay, so I'll proceed now and we'll take up the first topic for today, and that is what is machine learning? What is how machine learning works actually? This understanding many of you might have, some of you might not have, but let's just discuss so that we all are on the same page by the time we reach some of the advanced topics, right? So how traditional machine learning model used to works and how it has evolved over time to something that we can actually replicate and we can have a wider adaptation to these kind of algorithms, right? So traditionally, how machine learning used to happen, like it was some rules that were applied on some data points, and we used to have some outcome based on whatever the rule was. A good example in this scenario can be, let's say, there is a tap which is with the water is flowing out of it, right? And maybe you want to place, or maybe you want to put a check in here. In this particular scenario, the tap is our data point and you want to keep a check whether if the tap is open, maybe you would want to close it, right? But not in all the scenario you would want to close it. You also want to check whether there is a bucket or there is a glass beneath the tap, and in case the glass or the bucket is full, you need to turn off the tap, right? So this is some condition that you are applying. These conditions already exist. These are some of the rules that you have built, and you just want to apply the rule on the given data point, and you want to just achieve the outcome, right? So if the tap water is anywhere in your home, in your bathroom, or anywhere you will have, this rule will apply in that particular scenario, right? So this was some of the traditional condition-based programming that we used to do, and we used to generate the outcomes, right? But how machine learning has evolved is we first have the data, which is all labeled, sometimes unlabeled, and we tell or the algorithm that for this particular data point, this is the outcome, and the model through the journey of looking into the data, understanding the input and output, and it understand what needs to be done in what particular scenario. We are not defining any rules in this approach, but looking at the input and looking at the data, we are generalizing some of the rules within our network, within our model, and that learning helps us predict what will come in next. All right. So this is how traditional machine learning approach used to happen, and how we were using till couple of years back. Even now we are using it, which is more sophisticated. We have a lot of control in this particular scenario because the input and output is something that we are controlling, right? Also, there is all of you would have heard this. There is a good say in terms of data or in terms of data science, that is garbage in, garbage out, right? Which is how good your data is, whatever the input data point that you put in. The input data here includes the data points that you are going, which is your input, and the output. Whatever you give in the output and in the input, and whatever you show the output to the model, whatever it learns from it, that is going to be your final outcome. So whatever, if you have a garbage value inside your data setting, that will definitely make your model do some nuisance stuff when you are using that particular model, right? So this is some of the like I try to put this pictorially so that you guys can understand how the input in this particular scenario is our, or what is my input goes in and what amount out my output comes in. For this machine learning model, this is my, like, this complete is my input. This can be stock prediction data, it can be customer transaction data, it can be email text data, this can be any data point. You do some processing, you do some cleaning, you do some engineering on this particular data, and you feed in data, the quality enriched data to your machine learning model. There are a number of machine learning techniques out there in the market. Some of them we have discussed a little time before, like supervised, unsupervised classification. These are some of the techniques that we use for machine learning, and we make our model learn. When we say we are making, or we are the machine learning model is learning from the input data points, right? What actually is it is doing inside, we'll be discussing just in a while. But just understand that we are not making rules in here. Earlier we used to make rules, but now we are not making those rules. We are just showing our input and output to the model, and it is making its own rules, right? Yeah. So these are some of the basic approach if we broadly classify the machine learning techniques. Within each approach, there are again a number of technique, but broadly speaking, these are three machine learning techniques that you can group by based on what your input is, what your output is, how much you can interact within that model, what control you wanna have, right? This is where it is. So we have one called supervised learning. The other goes as to unsupervised learning, and then we have a reinforcement learning. How many of you are aware of these three machine learning techniques?
Yes, I'm aware with the supervised and unsupervised.
Okay,
I'm aware of all of three, supervised,
all of three.
unsupervised, reinforcement, but
Okay.
not in, in the detail level where we can be how
Mhm.
exactly we use.
Okay. Okay. So you do have an understanding of at broader level how things works
Yes,
in here. How much control do we have on a broader level,
yes.
and where to apply what kind of technique,
Yeah.
right? Yeah. I'm also good. Yeah, okay, great. I'm aware. Great. Then maybe we can just briefly touch up. Is there anyone? Okay, maybe I frame my question a different way. I should try it. So, how many of you are not aware of these three machine learning techniques?
Yeah, Ankit, I'm good, but still you can touch base with us.
Okay, sure, Samir. So,
You can explain the reinforcement a little bit, maybe that the first two were little bit, but the third one I think needs some input.
Okay. Sure, we'll be discussing all three so that everybody is able to understand and we all are on the same page when we are moving to the next thing, right? So, in supervised learning, supervised name itself suggests that you are controlling the model and you are supervising. From outside, you are supervising the model by showing the data. Here, the key important thing is you are telling your model, your machine learning model, that at what input, what should be your output. You are labeling the data that what goes inside and what comes inside. And based on that labeling, the model learns internally the pattern that it needs to recognize from the input to get output, what is the importance of what feature, right? That is a good example. If I give a good example in this particular scenario is a Titanic use case. So I'm sure many of you might have already solved this problem because that's where many of us, or I would say majority of us start machine learning. That the Titanic use case is a very popular one. So for those who don't know, so this Titanic data set has many data points. It is about the Titanic ship that was drowned in the last century. So it has the data points like the age, the class, the birth, the station they started their journey from, the ticket class, the ticket price, gender, and there are n number of features, right? Which goes as an input to your model, and then you have the target variable, which is whether they survived in the accident or they could not survive, right? So this is one of the popular problem that we start with. So in this particular scenario, if you see, we have all the input data points like their age, their class, their gender, their ticket and everything, how much they spent, which deck they were when the accident happened and everything. So all this information we have, this is my input data point that goes inside. So I'm labeling all this data that this is my input, and then we have a target variable, which is my whether they survived or not, right? So we are labeling, hence, so this is very like straightforward. You can understand that if you are labeling the data as input and output when you are triggering your machine learning model, that is an example of a supervised learning, right? For example, let's say you want to predict your house price, right? You are trying to build a machine learning model where you give what is the square foot, what is the number of rooms, what is the location, what is the like about if it has a garden or not, how many, what is the age of the house. So you are giving all these parameters to your model, and then you are training your model to predict the price. The input data that you have, let's say you have a 1 million records with all these data points, and you have a price of that particular house, right? And then you try to find the pattern. Okay, let's say location is an important factor that impacts my price of the house, right? Then number of rooms can be one of the important feature which has impacted my target price of this particular scenario. So these kind of examples can easily be solved through our supervised machine learning models. A good example in this particular scenario is a regression model, just like we discussed the house price prediction. This is example of regression uh, problem statement. The earlier one that we discussed, the machine learning was the Titanic one. That is example of our classification. We are classifying the data point whether they survived or not survived, right? So this is how supervised learning works. Then we have something called unsupervised learning. In unsupervised learning, we are not labeling the data whether it was well, like we are not showing the prediction to the model when we are training the model, right? And we are just giving the input, and the model is trying to group or classify the data into a similar pattern. Like if I say it is trying to find the pattern and group the similar kind of scenario in one place. A good example is like customer segmentation, like based on the customer's name, their credit history, their purchase history, and everything. You try to classify whether this particular customer is a good worth customer or it is something that you can let go. So you are trying to classify these kind of scenario where you are just showing your input data and you're not showing what can be the predicted output, right? This is an example of unsupervised learning. For reinforcement learning, it is a good example where neither you know input, neither you know the output, but you have a final target to achieve. So you try to explore each and every path you can take to reach to that particular output. And if you take a wrong step, you are penalized. Your machine learning model is penalized. And if you take a correct step towards your target, you will be awarded, right? So if I take, let's say, how many of you have seen that rat race that is quite popular in Western countries, where there's a maze and the mice needs to find the shortest route, or it needs to go to a particular location within the maze in the shortest period of time, right? So or any of the problem of this kind of and this kind of logic behind there, where your machine learning model try to explore each and every possible outcome, each and every step it can take to reach to your final outcome. Let's say you start a race and there is a finish line. You have a start point and you have a finish line, right? So your machine learning model, and there are millions and millions of iterations. It can be huge compute intensive as well. It can be time intensive as well. Let's say a machine learning model can take days or maybe months, depending upon the problem statements, right? So from the starting point, let's say it takes one step and it is awarded, okay, it has reached a little closer to my target, right? So it will be awarded. Let's say you take a next step, and then with the next step, you are getting away from your target, right? So in that case, you will be penalized. So this is how the reinforcement learning run. It works on the basis of awards and penalty, depending upon whatever the step the model is taking, right? At every step, there is a evaluation, and based on the evaluation, you get awarded or you get penalized. And when I say you, that means the model in this case. Do we have any more um, doubts in here? Or do we have doubts in here? We can discuss if you guys need
Are
more
we
discussion on this.
using this reinforcement learning somewhere in our journey?
In our journey, yes.
Okay.
Yeah.
So you will detail that time little bit more, I think.
Yeah. So if I briefly tell you, so let's say you have a generative AI model which is predicting something. Let's say it is predicting the next token, right? And you must have heard of RLHF. If I'm not sure if you guys have heard of or not, but we'll be discussing it in detail later on. So what it does is, for every output that a model predicts, it gets a feedback, and based on that feedback, it tried to correct whatever the next outcome is going to be. So that is called RLHF. It is part of my it is a very important part when we are building a LLM model, or when we are fine tuning a model. And the RLHF becomes very important. It's reinforcement learning with human feedback. The human is giving the input, whether it has to be awarded or whether it has to be penalized, and based on that, this feedback goes inside the model, and it adjusts things inside to get the next output based on the feedback. Was I able to help you understand this?
Yeah.
Okay. Do we have any more questions you can take? If you do not have a question, put a no in the chat so that I know that you guys are following me. Okay, great. So in that case, we can move to the next point of discussion that we have agenda for today, and that is a neural network. What is a neural network? How many of you are aware of neural networks? It is a little advanced machine learning model only. There's no rocket science inside. It's the broader parameter remains the same, that you have an input, you have output, and you try to make model learn how the output is achieved from the input. How do we decide which classification technique we should use? So it completely depends on the kind of problem statement that you have. There is no one size fit all kind of scenario. Even after you decide what model that you are going to use, even after that, there is a lot of what do I say? Uh, so it is called hyperparameter tuning in terms of like machine learning terminologies. It's like you are tuning in something, right? Just like you tune in your engine. The engine is ready, but you need to tune it for certain performance, right? It's not that all the engines are going to perform the same, which has the same, let's say, numbers in terms of how many horsepower, how many what is the torque and everything. You need to tune the engine for that particular specification. Similar to that, we have our machine learning model for which once you have decided your model, which model that you are going to work with, there are specific parameter inside that model that you need to tune to get a better outcome. Some of the important techniques to improve your results, or for it is applicable for all the machine learning model, all the neural network is there is something called feature engineering. There is something called data pre-processing, where you are preparing your data to be consumed, and you are not putting in any garbage inside your model, right?
Okay. So
The
you are
feature
saying that,
engineering,
once that,
yeah.
so,
Yeah, please go ahead.
sorry, so you were saying that once I decided my, classification technique, whether it's I'm
Mm-hmm.
enforcement or going for unsupervised, after that
Mm-hmm.
I have to decide, what kind of a model, like if I am going for a sequential model or any other model, or what kind of a dense layer I have to use it. So this is all
Mm-hmm.
depend on what kind of prediction or what kind of accuracy I required it by using all these things like loss of function, which I'm going to use. Have to use it. Kind of
Yes. Uh, your voice is
sorry,
breaking.
if you don't mind, I'm asking you so many questions.
No, that's good for all of us. If you're asking a question, that will help all of us to get a better understanding of the topic that we are discussing. So don't bother about that. But let me just clarify what I understood because you were breaking in between. So you want to understand, um, like after deciding what machine learning technique that we want to use, either it is a supervised or it is unsupervised. After that, there comes the hyperparameter tuning that is depending upon the machine learning model that we are choosing, right? I'm sorry if you are speaking, we cannot hear you.
Yeah, that was my question.
Yeah. So, okay. So you can solve the same problem with different approaches itself, right? You can solve this Titanic problem statement that we discussed, right? You can solve this
Mhm.
problem with your supervised learning as well. You can use the same problem statement to get the prediction through your unsupervised learning as well. But the results depending upon what accuracy that you are expecting, right? Let's say you try supervised as well as unsupervised learning, and you are doing tuning, not very exhaustive hyperparameter tuning, but just to select which approach you should go with. You are also doing some sort of tuning inside your model so that you can go deeper into the tuning and get the best out possible outcome. And the same thing you can do using your neural networks also, right? It is not that if you are applying or a problem statement that can be solved through only one machine learning technique. No, you can apply different machine learning technique as well. But
Thank
that again remains to be one of you guys mentioned that uh, they do machine learning technique, they do classification modeling at their workplace. So it is never, maybe they can share the experience. I think it was Shravan, and he mentioned, maybe Shravan, can you speak up and share your experience, how you approach a problem statement and how do you finalize a machine learning um, technique that you want to use for a specific problem statement?
Yeah, hi, Ankit. So So yeah, so basically like yeah, once we choose like which process that like which we want to do, like either supervised or unsupervised, that unsupervised if you want to check like regression or classification. As you said, like we'll be starting with data cleaning. So if there are any like missing values or any outliers, all these things we'll be checking. We'll clean the data, and then we'll be working on like pre-processing. Everything is like interlinked, and then we see if we can create any new features, as you said, like feature engineering. So like from the existing features, or use any other features from the existing data set that can be maybe useful in our model building, that can add some information to the predicted variable. So we'll be using feature engineering, and
Yeah.
then we'll be starting with like in real time, like yeah, we could go through the data, like if there are some, if you see any like variance and all those some statistical analysis, then we can say we can start with like if there is huge variance, then we can go for some ensemble models like random forest. Or like if you want to start with some simple models, we could start with like, if it is a classification, we can start with logistic regression and a simple decision tree, and go with random forest. So we'll be comparing like a base model. Will be first we'll start like we'll come up with some base model out of these all these algorithms. Let's say if we come up with some random forest, then we'll start like we'll focus only on random forest, and we'll start hyperparameter tuning for that model. So we'll try different tunings, like some like grid search, we'll use some cross validation,
Right.
all those things. And
Yeah.
yeah, this is a process.
Yeah. Okay, so how many of you did notice that he mentioned that we try different approaches? We start with the base model and we try approaches and we compare the result, and whichever is giving the optimum results. Let's say we take top two or top three across different models. Maybe sometime we need to use ensemble. Ensemble means you are taking two techniques and adding up their results to get a better outcome, right? You experiment around this. It's never that you hit a problem statement with one approach and you get the best one. Maybe if you would have tried some another approach, you might have got some better outcome, right? And the evaluation of each problem statement, each technique that we use can be a different, right? Like he mentioned, that we can ensemble the results and compares. For, let's say, we can have confusion metric, we can have accuracy, we can have precision, we can have recall. These are some of the metrics, evaluation metrics, on which you decide whether the outcome of the techniques that you have used, if it is something that you can live with or you want to improve, or how is it like, right? Were you able to grab it? Have I made it clear? Okay, thanks. Thanks, Ashwat. Do we have any more questions?
See, the model deployment is part of this course. Means whatever we make it, the basic
Uh-huh.
gap is the how to deploy that in a production or production scale. Uh,
Uh-huh.
that is covered in our
Okay.
session.
Okay. So, this particularly for this course I am referring to, this is primarily towards generative AI, right? The session that we are discussing right now, starting from machine learning model, then we'll be moving to neural networks, then we'll moving to transformer model, and then to the generative AI models or the large language models, right? If you want to build and deploy a large language model application, then yes, that would be part of our curriculum. But if you are referring to the traditional machine learning model, you can build and you can deploy those applications. So that is not something that is part of the curriculum as of now. But I'm sure there are other sessions where you will be learning this, right? But we will be discussing how a model is built, and it is same. Like if it is a machine learning model, the same goes with the neural network, because neural network is also a machine learning model. Same goes with the large language model, because that's again is a machine learning model. It's just that they are at a different level of sophistication, different level of complexity. different use case are different for all of them, right? But yes, we will be deploying some of the application that we are going to build, and we are going to uh, build a demo use case around that as well. I'm not getting any voice. Are you guys able to hear me?
Yeah.
Yes, yes.
Okay, then Samshir, maybe you would want to uh, check if something is wrong with the earpiece that you're using.
No, no. Now I'm getting your voice. Thank you.
Okay, great. Yeah. Okay, so was it helpful? You got your answer? You're
Yeah.
speaking, we cannot hear you. Okay, thanks, Ashok. So moving to the next level of sophistications, which are our neural network. Moving forward from traditional machine learning models, the neural networks are more sophisticated. When I said earlier the hyperparameter tuning, there we had limited number of parameter that we can tune in, right? But when we move to neural network, the level of sophistication increase, the level of compute increase, the accuracy definitely takes a hit. When I take a hit, it definitely increases because we are including lots of input parameter inside, right? And if I talk about simply what a neural network is, the natural neural network, if I talk, it is our brain. How the information is flowing inside our brain, right? How the response goes in. The input to our brain are our sense organs, right? So the input to the artificial neural network is our data that goes inside, right? So this neural network definitely is a huge complex network in inside, but it works exactly the same way our mind works, right? It takes in the information from all the sense organs that we have, it processes it, and it generates action around that input that we have got. So just think of a neural network that is a replication of our brain. This is an algorithm inspired by human brain that processes information and makes predictions. In this case, this is a prediction. In our case, the neural network that we have in our head, that's the action that we take. That's the prediction accordingly, right? And it consists of neuron. What neurons are, we'll be discussing. But just for now, it consists of neuron. Neuron is a like the basic, just like in our brain, one neuron is the minimum or the smallest entity inside our head, right? Where the information flows in through. The neurons is again the smallest data processing unit inside a neural network, which process the data and provides the output. It takes the information, do something, some calculation, something that is configured for this particular neuron, and it transfer the output to the next one. The next one can be again a neuron, the next one can be a output as well, right? So the neuron is the smallest building block of our neural network. And when we talk about the architecture of our neural network, it includes primarily three layers. What three layers are? This is one of my layer is input layer. The other one is output layer, and the one that is critical or most important is this hidden layer. All the magic happens inside this input, this hidden layer, right? The output layer, let's say, you can have something. Take it like you have some input in here, you have some output in here, and there is some black box in here. You gives the input, and you takes the your output. Okay, I think this pointer is not being great. Can you see the screen, right?
Yeah.
Yes.
Okay. Uh, so let's take this is as one layer, this is as another layer. So this is my layer one, this is my layer two, and then we have another layer. This is my layer three, right? So this layer two, which is called my hidden layer, this is my hidden layer. Take it as a black box. And when I'm saying black box, we will know what calculations are happening. We will know how these calculations are happening. Each and every neuron we can control. But from a broader architecture point of view, this is a black box where your input goes in. and some processing is happening in my hidden layer or the black box that we have, and then we have some output coming up, right? So this is a basic architecture of a neural network. Yes, there are different neural network configuration. This hidden layer, different configuration of this hidden layer gives us different kind of neural networks. When I say different kind of neural network, we'll be discussing some of them in detail. Um, but take it like these configurations decide how your output will be, how good your output will be. Just like you were doing hyperparameter tuning in our earlier approach, here this hidden layer magic will decide what your output or how good your output would be, right? So let's move to
Ankit,
the next one.
Ankit,
Yeah,
that hidden layer, like what I'm vibing, this is like a dimensionally reduction kind of thing. Means feature
sorry.
engineering kind of thing, where you're reducing a feature, increasing a feature.
Uh, No, no, I would differ in this particular scenario because when you are giving an input to your neural network here, this input is already processed. And when I say processed, I mean missing value treatment. I mean,
Yeah,
if there
EDA,
is
EDA
a
is done.
EDA, you have done all this EDA, you have prepared your data, and then you have also done some feature engineering.
Okay, feature engineering also happens.
Yes, everything is done before you feed your data inside your model. Just like your earlier machine learning approach, you are processing your data, you are preparing for your data, right? And then you feed into your machine learning model. The same approach happens in here where you are cleaning your data, you are processing your data to be fed into your neural network, right? Inside this, earlier used to have machine the hyperparameter tuning. Here we tune our neural network. We have uh, some of the techniques through which we control what will happen at each node, right? So what a layer is, if I build easiest or the simplest neural network is, let's say you have one input layer, and then you have a middle layer which has two neurons, and then you have an output layer, right? So this one set of neurons, this one set of neurons which are in parallel, this is called a layer, right? This is one layer. This is another layer. These layers are named as input layer, hidden layer. Hidden layer can be, currently I have built just one layer, like one layer of neuron. It can have n number of layers of neurons, right? It can have 2, it can have 10, it can have 100, it can have 500, depending upon whatever the use case you build, right? Also, there is something called overfitting and underfitting. How many of you are aware of the term overfitting and underfitting?
Yeah.
Yes. Okay, Samshir also knows, Ashok also knows. Maybe I should have asked how many of you do not know what this overfitting and underfitting is. Is there anyone? Or should I assume that all of us know? Okay, Kalpana does not know. Okay, maybe if someone wants to speak up and help us understand what overfitting and underfitting is. Okay, Reshma also needs more clarity on this. Okay, so maybe if someone of you can unmute and maybe we can discuss, or maybe you can share your understanding of what overfitting and what underfitting is. Yes, maybe Shravan, you can go ahead, or Shamshir, you want to go?
Yeah, sure. I'll go.
Okay. Yeah.
So so basically, in a high level, like underfitting and overfitting is like how well your model is learning.
Mhm.
Those patterns. Like earlier we discussed, right? Like Ankit has said, like rules. So in general,
Mhm.
how well your model is learning those rules. So underfitting is like it's not learning those rules the presented like in actual like the actual rules that are present in the data. It's not learning that much, so it's not fitting. Like if you assume that the learning is a curve, that curve is not like exactly fitted, it's underfitting. It means it's not
Okay.
learning that much from the data. Overfitting is
Uh,
like it's learning too much. I mean, like it's not like basically our model should be a generalized between trade-off between underfitting and overfitting, like a generalized model which
mhm,
learns like optimal rules, which should
mhm.
not exactly fit to the data that we are giving as a training. So this is like on a high level, like underfitting and overfitting.
Yeah, correct. Thanks for sharing this, and definitely this is something that actually inside the concept exists. That is what underfitting and overfitting is, where it's always a trade-off between underfitting and overfitting. What is your optimum fit to the prediction? And when we say fit, is like what your model is predicting. Is it something that you can live with, or is it something too much stuck to your input data, or is it too much away from even your input data? Maybe if someone wants to add to it, do we have some more points? If someone wants to add
Yes.
to what Ashok has
Generally,
added.
underfitting is like your linear regression, and overfitting is like something if you have a too much of um, deep neural network, then it will be overfitting. So sometimes
Yes,
we
that
have
is
to
a very good
drop.
example.
Yes.
Yeah. Okay.
Sometimes we have to drop in between middle layers
Mhm.
to tell model not to be overfit.
Yes, that is 100% correct. Okay, if anybody wants to add to it, maybe now is the chance.
So the underfitting is very less noise with the data, and overfitting is
Okay.
the more noise. Like the data which we are giving to the model as an input. So they are doing well defined. The accuracy. It's showing the accuracy is very high. So
Mm-hmm.
that is the overfitting. So there are a lot of noise in the database data itself.
Yes.
It's
Mm-hmm.
saying that data is either only a one-sided, completely a one-sided. So
Mm-hmm.
that is called overfitting. And underfitting is that if we are using a data, the noise of the data is very low. That means there is nothing is available into a one-sided itself.
Mm-hmm. Correct. You mentioned a very good point in here, that is
Yeah.
biasness. If your model is biased towards the data that it has predicted, right? That's
It's
a very
kind
good
of
point.
memorizing. The overfitting is kind of memorizing for that data set. So it may
Uh-huh.
fit very well for that data set which we are training, but may
Uh-huh.
not be giving the good result for the test data or other real-time data.
Unknown
Okay.
data. Yeah, unknown
Yeah.
data.
So unknown
Correct.
data, it may fail to give a accurate result. So it's
Yes.
too much of learning that it customized or maybe memorized the data. It's like that.
Mm-hmm.
So that
Correct.
is
That
one
that's
point. Yeah.
yes, that's a
This.
bingo. That's to the
Yeah.
point. Yeah. So
Yes, the
Kalpana
second thing
and
is, yeah,
yeah,
sorry,
please
yeah,
go ahead. Yeah, please
yeah.
go ahead,
The
Ashok.
under this one is actually there the errors are high, where
Uh-huh.
the model is not learned to predict actually what is there in the data. So there
Mm-hmm.
you will get a accuracy will be very poor, and
Mm-hmm.
it won't even work for the your maybe trained data.
Mm-hmm. Correct. That's exactly to the point definition of this. If I go, Kalpana and Reshma, were you able to understand what we all were trying to discuss when we say it's learning from the values that were there in the input, and it's hard coding those values. It's not actually taking the essence out of it. It's like you are mugging up things. You understand the question that were there in your class 10th mathematics books, that all were there in examples or in the exercise. But if something new comes up, you just go blank. What has come up, right? Because you are not actually learning the logic inside how the calculations were happening, how the input and output has come. You were just mugging up things, right? Or when I'm saying you, that means the model is in this particular scenario is just mugging up things. It is just learning what input and output was, and not actually learning the pattern that has flown from input to the output. That is what my overfitting is. So that you are over mugging up or over learning from that particular data point. A good example, if I tell you, is let's say you are learning to drive a bicycle, right? And you start it from your courtyard. You start like pedaling your cycle, and let's say within a couple of days or maybe in a couple of hours, you are able to drive from your courtyard straight, right? But when you jump to the road, roads are not always straight. There can be curves, there can be turns, there can be sharp turns, there can be anyone randomly jumping in your way, right? But your learning was always on something that was already always a straight line. So you have learned that straight line, but when you are looking at an unknown scenario, when you are looking at something that was not available in your training data, the model goes blank, right? That is what my overfitting is. Underfitting is when your data point has values. Your data, if you would have trained a little more, you would have got the pattern or got the understanding of your data. Your error rate is high because you are not actually learning from the data. You are still missing on the scenarios where you could have learned. Or when I'm saying you, I'm referring to the model. That model could have learned, right? So that is always a trade-off between underfitting scenario and a overfitting scenario. How do you come up to a optimum point where you are confident, okay, whatever the model has learned till this point of time is good enough, and model can now handle all the unknown scenarios. Kalpana, Reshma, and all, like, are we clear? If you have a doubt, please go ahead.
So, Ankit, might be
Yeah.
I'm wrong, but generally skewness will give the better understanding. It's going to overfitting or underfitting correlations in between.
Yes. So that's how you measure. When someone of us mentioned that the curve line, where when it is over the curve line, over the curve or under the curve, that's how we know if the model is like underfit or overfit. The example that I would want to mention in case of my underfitting is whatever the data that my model was trained on. If I expose the same data to the model for prediction, it is not able to predict correctly. That is an example of my uh, underfit scenario. You are driving the bicycle in a straight lawn, and when you are driving the same bicycle in a different lawn or the same lawn, you are not actually able to drive the bicycle. That is an example of underfit.
Yeah, makes sense.
Yeah. Uh, Kalpana, was it clear? Were you able to understand? And how about you,
Yes,
Reshma?
yes, it's clear. So it is
Oh,
like
okay.
a evaluation. Like if I'm supposing the result should be 1, if it is 0.7, that is under, and if it is 1.2 or 3, then it is at over.
Yes,
It
sort
is
of, you
like
can
that.
say that. Yes, yes, you can sort of. For your understanding, you can take it like that. But it is not a number per se. It is a concept where if your input data is, when I say input, your training data is exposed to the model for prediction and it is making a huge error. That means that scenario we are referring to as a underfit. And if in case your model is predicting only on your training data and not able to predict on your unknown data, that means it is a overfit. It's a concept in there, and you can draw a line out of it also. That was the line that we were mentioning earlier, that we discussed earlier.
Yeah, okay.
Yeah. Uh, how about you, Reshma?
Yeah, it's clear, clear. Yeah.
Okay, great. So maybe now we can move on to the next slide that we have for the discussion. That is some of the key terminologies that goes inside my neural network, or what is happening inside my neural network. So before we actually understand what is happening at overall architecture level, we just discussed what is happening at overall architecture level. Let's just move exactly opposite and let's understand what is happening at single neuron level, right? Until now, we were learning what is happening at a broader level, what was the architecture, input, output. There is something in middle, which is a hidden layer, and it can have n number of layers inside. It can be in different arrangements as well, which is called my hidden layer. Now let's just understand what is happening at my single neuron. This is my single neuron in this particular scenario. If you see, this whole, this is my one single neuron. This is the calculation that is happening inside my one single neuron. So how many of you remember there is there is an equation of line that we used to learn in our schools, that was y is equals to mx plus c. How many of you remember this equation? Yeah. Okay. I'm sure everybody remembers this equation, because that was the first equation that we all learned, and this is still getting used, right? So in this particular scenario, this y and x, these are something variables, right? It will vary. This x is my input, and this y is my output, right? And for this input and output, we used to like, even in our schools, we used to find out what is my m and what is my c. We used to find all of these both terms so that we can fit a line which is best suiting that particular equation, right? Whatever my input comes in, whatever my output comes in, we will usually need to find out this slope in this particular scenario and a constant. In terms of neurons, what we call these as this m, which was slope in there, this is called weights. And weight means what is the importance of my this input metric that is coming in my output. How important is this particular metric is. In case of when we have only one single input, then this is the only one that is impacting my output. But if in case we have multiple input, so let's say we have an equation like y is equals to m1 x1 plus m2 x2, here with my writing, plus m3 x3 plus c, right? So in this particular scenario, we have three different values of x which are impacting my y, or this is my independent variables, x1, x2, x3. These independence variables are impacting my target variable, that is y in this particular scenario, that is a dependent variable, right? So these m1, these m2, these m3, these are my weights. In terms of when we come to our neural networks or the machine learning models, we call them w1, weight 1, weight 2, weight 3, right? So these are the input weight. This is the importance of a particular feature that it holds in my current scenario, right? So this is my simple equation that happens actually in my neuron as well. We have input layer coming in. So this x1 you see here, this x2 here, this xm here. These are x1, x2, x3 till m. These are these many input we have. This is my input layer that is in here, right? So for each input that is coming in, we are multiplying some weight. Here we are multiplying some weight to my input. What is the importance of that input in my current scenario, right? And once we have the W1, X1, W2, X2, W3, X3, then we add something called bias. The C in our equation from earlier, this y is equals to mx plus c. This C is called bias. Bias means if you add this C used to called as intercept in our school days, right? Here, this C is that constant through which if we move our predictions a little left or a little right, or we adjust our predictions, then we can have the optimum results, right? This is the way we try to neutralize the error that has come up, which we could not capture through weights, right? So this is called bias in this particular scenario. So the only thing that we try to come up with when we are training a neural network is this weights and biases. Each layer will have its own weights. Each layer will have its own biases, right? Each neuron will have its own weight and bias, right? So once we multiply this x1w1, x2w2, x3w3, we add all of them together with the biasness term also. So now our equation will become x1w1 plus x2. Array. I need a eraser. x2 w2 plus x3 w3 plus there is some biasness which is, let's say, b in this particular scenario. So now this is my equation that comes up till this point of time. This is my equation, right? Now comes the very important part that goes inside my neural network. This is one of the important thing that decides decide of how our neural or how our neuron or what is going to be the output from my neuron, right? What we do, whatever the equation that we have got in here, or whatever the equation or whatever the processed input that we have got till this point of time for that particular neuron, this is something called activation function. Let's say you have the processed input till this particular line, this output was, let's say, 0.7, right? And you are using a simple function that if this input is positive, then make it 1. If it is less than 0, then make it 0. You are simply using this function, right? Whatever the input comes to this activation function, this activation function decides whether this neuron is going to be active or will be inactive in this particular scenario setup, right? There are different activation functions as well, but on a broader level, without going much into complexity, just take it like whether this particular setup of neuron that we have just done, whatever the calculation that we have done this till here, the output of this, when it is feeding into my next neuron, whether this is going to be active, whether this is going to be inactive, what is the information that it will pass from one neuron to another neuron. This is the function that decide what goes to my output, right? Were you able to grab this thing? How many
So
of
that
you?
means the activation
Yeah.
function decide the out.
Yeah, please.
So that means the activation function decide the output of this particular neuron will be transferred to the another neuron or not, right?
Yes, yes. Not just if it will be transferred or not, how much it will be transferred. Whether so there is a say this whether this neuron will fire or not. If it is an active one, that means the neuron is firing to the next neuron. If it is not, then it is not firing. This is uh, if I can take an example around this, is like if something comes up, let's say you start feeling hot. The temperature is rising slowly in Delhi, and if it is within a limit that you are okay, like I do not need a air conditioner, maybe a little fan is okay. That's okay. But slowly, as soon as temperature rises, you want something, right? You want to change what your output was in the earlier scenario when the temperature was below 20, 25 maybe, and when the temperature is hitting 30 or 35 or 40, right? So what your output is on the different input condition, you are processing it in a certain way, and then your outcome is okay. You want an air conditioner now, or okay, maybe you want a fan. That's it. Maybe air conditioner. The temperature is not enough, so that you need an air conditioner for that. So this is that activation function that decide what is the optimum or what is the limit which you can bear in this particular scenario. If I talk about how much you can bear and when at what point of time you need to show to the next neuron, right? Were you able to get it? Okay, I'll take the silence as yes. If you have any doubt, please go ahead. We all will discuss and we'll make sure that you have clarity on whatever the doubt that you had. Okay. Uh, yeah. So now we have discussed neuron, we have discussed weights, that how important that input parameter is. in our neuron, and we adjust these weights depending upon adjusting these weights is what we call as training, right? You flow the data through my neural network. Each neuron will through pass the data, and you will adjust the weight so that you get a optimum output that you are expecting for that particular set of training, right? Higher weight means higher impact on the distance. So if in this equation, this x1, x2, and x3 or xm that we are going to have, the higher the value of no, not x1 but the w1, the higher the value of weight, that means that particular feature is more important compared to others in that particular layer, right? So that's what my weight is. Biasness is a constant value that helps shift my output for a better learning of my neural network. Activation function is something that will decide that we have discussed whether my particular neuron is going to fire or not through my next neuron. Now there are some more terminologies. Something like layer that we have already discussed. This is a organized connection that happens within a layer, that is that neurons are organized together, that forms up to a layer, right? This forward propagation is, so let's say you had one neuron, and this neuron is passing on something to the next neuron. So you have let's say one layer, this is my layer 1, let's call it L1, then you have layer 2, this let's call it L2, then you have layer 3, you call it L3. You have input layer, let's say this is my input layer, and then you have a layer called output layer, right? So your input is passed to L1, your L1 is passed to L2, L2 is passed to L3, L3 is passed to output. So this is my forward propagation of information that is passing through my neural network, right? Uh, are we on the same page? Okay, I will take the silence as that we are on the same page.
Yeah.
If you have any doubt, please. Yeah. Do we have any doubt?
So layers means in different electrons, right?
Sorry? I could not understand. Could you please come again?
Layers means different neurons.
Yes, each layer can have n number of neuron in itself. If I can make it like this, and there will be connection like this. So each neuron will be connected to each neuron in a different layer. So let me try to build a simpler one for you, right? So this is my neuron 1. This is connected to this, right? Let's make arrow sign as well so that you understand. And this is connected to this and this and this. Now this will connected to this both. This is connected to the I made a mistake. Will it not delete? I don't know. Okay, so this is not there. This is here, and then this is here, and this is here. So if you see, each neuron is connected to all the neurons in the next layer. Here, each neuron is connected to all the neurons in my next layer, right? So this is what I am calling as a layer. This is what I am calling as a layer. It can have n number of 2, 3, 4, 5, 10, 100, thousands or millions of neuron in one single layer, right? And when we pass this information from one layer to another, this is called forward propagation. From input to output, when you are passing the information, that is called my forward propagation. And exactly the same way, when we are passing the information in reverse, that is called backward propagation. Input to output is forward propagation. Output to input is backward propagation. Why we need backward propagation is, okay, so let's say you had some weights given. Let's say you started with some value of W1, W2, W3, Wm, right? And then you have some output in the predictions, right? But your output, you evaluate your output, and then you decide whether your output, how far you were from your actual value. That's what we called a loss function. You decide how much loss or how much wrong you are in that particular scenario. And then you use this error matrix to pass back and adjust your weights, right? So it goes in the loop where you make a predictions, you find the error or the loss function, and then you go back and adjust your weight, and then you make a forward propagation, then you adjust the weights. This goes in the loop, and that's how your neural network works, right? This here is something called loss function. Loss function is like what is the difference between your predicted value and your actual true value, right? And based on that, you will decide, okay, what my error was and how I need to reduce that error. You need to pass it back. You need to update the weight in the layers, and then you pass the next information, right? So I hope you understood the terminologies of forward propagation, backward propagation, what they actually mean. In loss function is again when I mentioned at this layer, you calculate what is the actual difference that you are getting in your predicted value and your actual true value that you had, right? And there is something called a gradient descent or the optimization algorithm that are there, which helps you adjust your weights and biases so that you can minimize your loss function. This gradient descent or the optimization algorithm is again a separate topic in itself. But if I give you briefly, let's say this is your curve, this is your curve, and you want to find your minima in that particular curve. And when I say minimum, that means the lowest point that you have, right? Let's say you had a curve like this, right? Here, let's say you started learning from here, and then you are trying to find the local, or you are trying to find the minima of this particular curve. And I'm giving you from a very broad level what my gradient descent is and how it works, right? You can definitely look for it in detail, but just so that we are discussing and we are not missing out on the information. You take a step. In the next step, you see what was my previous step and have I reduced, or what was my error lower than what my previous error was. If say yes, you take the next step. Okay, so if you are moving further from the previous step, you are coming down in terms of what your error was. Let's say you are hitting here, right? From point, let's say we call it P1, and let's say this is my P2, right? Your P2 is lower than P1. When you do P1 minus P2, yes, you are getting a lower error. But let's say this point here, P3, right? If you go for P3, that means your error has increased. You would want to settle up, okay, P2 is something where I am getting a minimum error, but there is also something called as local minima and local maxima, which is your P2 point is not actually the lowest error. Lowest error was here something, let's say this was P minimum, PM, let's say we call it. But you are hitting to a point called P2, which is in this particular scenario till here, it was a local scenario where you were hitting the minima, but you would want to explore it further and see if this is actually my global minima or not, right? And the steps that you take in here, that is something called what is going to be your learning rate. If you want to keep your steps bigger, let's say you take one step here, one step here, one step here. If you take this bigger step, that means you might miss the information between this step and this step. You might want uh, to you might miss some of the information in here. You might miss your actual global minima. But if you take your step bigger, you might reach your global minima faster, right? So this is some of the trade-off that you do. When you are making your neural network learn, you actually define all these parameters. What is going to be your learning rate, right? There is also something called as epoch. Epoch is like how many iteration you wants to do for your input data, through how many times you want to pass your input data through your neural net so that your model is able to learn. If you do too much of epoch, that means there are chances that your model might overfit. And if you do very lesser number of epoch, that means you might be on the underfit. So again, this is a trade-off between underfit and overfit, right? How many of you do have some doubts in here? Again, this gradient descent itself is a algorithm where this itself is a like 2-3 hours of topic which can go in detail. But for now, let's keep it here, and we have a understanding of how my gradient descent algorithm works, how we can
We'll
optimize
be
our
going in
model.
detail in upcoming classes for gradient descent and backpropagation.
So if we end up in discussion for gradient descent and optimization algorithm, we might miss on other topics which are there in the curriculum, which are primarily the courses for which the curriculum has been decided, right? So this is something that I'm taking up so that we all or we all are on the same page. We actually understand what goes inside the language model, how the language models are trained, how. So if you, I'm not sure if you guys have heard of, there is Llama model like 70B. Have you guys heard of this model Llama? 70B Llama. There are model like 7B, 3B. There was Mistral,
Yes, yes.
which was 7 into I think 30B. I'm not sure, but there was something like this. So what is the actual meaning when it says 70B? We understand it has 70 billion parameter. What are those parameters? Those parameters are these neurons only. So they have 70 billion parameters which are trained through the data, tuned through the data. They had calculated these loss functions. They had calculated this forward propagation, backward propagation. All these things is happening inside that neural network as well, right?
Are we covering
So
this fine tuning, this MCP agent and all?
fine tuning and MCP agent are two different things. Fine tuning, yes, we will be definitely covering up. MCP agent is something, if you want, we can take it up. If everybody wants and we have enough time, we will definitely take it up into our
Because the
curriculum.
MCP is the latest one which is in the market. So the
Correct,
agent and
correct.
the agentic will be also there, part of this.
Yes, yes, we will be
So
having agentic
MCP also
architecture
please
as well.
try to cover because that will be
Yeah,
very useful. Yeah, yeah.
sure, sure. I'll take a note of that and definitely,
Also, are we
if time
covering
permits,
any tool like N8N wagera that workflow
tool
automation?
like
N8N.
NA10.
N8N.
Okay, if you want, we can, but how many of you are comfortable with coding? First of all, tell me that. How many of you are comfortable with Python?
I can understand, but I'm not a hard coder. But I can understand and I can tweak it with the help of
Uh-huh.
GPT or maybe
Uh-huh.
internet.
Okay, so maybe everybody might not agree with me, but what my like this is my personal understanding that once you start getting hands-on of what is or how things are happening, when you start writing your code, when you actually debug your code, when you actually try to optimize your code in different scenarios, right? You actually fell in love with the way things are working in there. I
Yeah, this
started.
cursor AI and all. If you are able to, when we do something, now we can use the cursor AI or that kind of coding
Mm.
tools. Na?
Yes, it's faster.
Where,
Yes, it gives you better visibility. It gives you,
yeah, where we
uh,
can debug our own codes and all. It
yes,
will help while
exactly,
we learn. Yeah.
exactly. I remember back at my place, we were exploring. There was something called, I think, Langflow, where it is you can use just pick and drop all your tools, whichever you want to use, and you can start using it. But then again, we were ending up in error, and I had to take the code from there and debug it and then use it. So it's not always correct, but yes, we can, if time permits, we can definitely take it up into our discussion application like N8N or Langflow or something like that. Yeah, I'll
LangChain
take it
and
as a
LangFlow
note.
will be part of anyway. LangChain will be there, I think. Correct.
Yes, LangChain, LangFuse will be there. So if someone is not able to understand what LangChain is, what LangFuse is, what LangGraph is, don't worry, we will be covering up all these details in our coming sessions.
Also, we'll be trying some offline models like using Olama, that kind of things.
Yes. So there is something So we are not going to restrict to one single model. We are going to explore different models that are out there. On Hugging
Okay.
Face, they are available, and hosted
Yeah.
they are available. If you have like resources available, and when I say resources, you have enough compute, you can also install the model on your local hardware, and we can try it,
Yeah.
and we can use it from there, right?
Yeah. We
Yeah.
can try at least up to 7 million or something. It will work, I think.
Yeah.
Maybe two, or there will be small one also available, I
Yeah,
think.
I tried. I remember there was a model called Phi. It was by Microsoft.
Yeah.
Not a very good model, but I tried it on my local computer and it was working not so great, but yeah, it was fine. So we can do that. Don't worry about
Yeah.
that. Yeah, if time permits, we will definitely do that. So I'll take a note of this as well, right? So we have three things to note. One is NA10. Other one was, can you highlight if you guys are, if you guys remember what we have discussed?
MCP, NA10, and model difference.
MCP, NA10 and
Fine tuning,
fine tuning. Okay.
and then agents are already there. Blank chain, lang, or whatever is there. That line graph, line chain.
That is already
Mm.
there. I'm
Yeah.
yeah.
Then multi agent will be there, right? Multi agent agents. Then
Yeah, agentic
MCP.
architecture will be there. You can
Yeah.
use it obviously, and you can evolve this architecture based on your use
Rags,
case.
rag will
RAG
be
will
there,
be
right?
there. Yes, RAG will be there. We'll be building hands-on application on RAG. I already have that in the
Vector
curriculum.
database also will be covered,
Yes,
right?
we will be
Vector
having.
database.
Yes,
Yeah.
yeah. Okay. I think we should move to the agenda next point for today. We are little short on time on there. Okay, so what are different types of neural network? Right now, till now, we were discussing on a broader architecture of what neural network is, how it looks like, how internally a single neuron does all these calculations, and the calculation that we discussed that was happening at one single neuron. Imagine there are billions of neurons, so this calculation is happening, the feedback is going back, and the weights are updated, and that's why the neural networks are a little resource intensive because it needs to do all these calculations at the back end, right? So some of the example, if I talk about, or what are different types of, and I'm doing this on a very broader level based on how the information flows through my neural network, what are the different use cases that particular different neural network use can solve. And this type depends upon how my internal or how my hidden layer is configured, right? REST, input, output, the hidden layer, overall architecture remains the same. Individual neuron calculations remain the same, but how they are organized, how I am leveraging the capability that neural network provide me, how I'm modifying it, how I'm using it, how I'm consuming it, defines what different kind of use case a particular architecture can be able to solve, right? So one of them, and that is very straightforward, is the feed forward neural network. In the feed forward neural network, the information is passing from input to output. Mm. And in between, we have something called hidden layer, right? This is a typical, the one that we discussed is a feed forward neural network. It does not have the backward propagation capability, and it is very like simplest neural network if you can build. There can be layers in between, you can build a number of layers, but it does not have the capability to update the weights based on the error or the loss function that you are getting. And this is something called as feed forward neural network. Then we have something called recurrent neural network, or RNN, as they are called, RNN neural network, where the feedback loop does exist, allowing it to process sequential data. So when I say feedback loop, so the feedback can be in two ways. One is, let's say this is one neuron, this is another neuron, this is in my one layer, and this is in my second layer. right? Let's say these are neurons in this, and this layer is giving a feedback to this particular layer. So this neuron is giving a feedback to this neuron, this neuron is giving a feedback to this neuron, and this neuron is giving a feedback to itself also based on whatever the output it has got. This feedback loops goes in, right? So when you are putting in a serial data, the serial data can be a time series data. When I'm saying a serial data, that is serial in temporal basis. So let's say you have a data point from one date, second date, third date. It is temporal data. It is flowing in time, right? That is my temporal data. That's where these kind of neural network can help in, because you have something coming up, and the next value or the next input that is going to come up, your model will learn based on the current value, and when the next value comes up, your model is ready for that next value, right? The serially information flows in serially. The input in here is serial input that goes inside, and your model do that feedback updation and everything, and your model is ready for the next iteration when the sequential data comes in, right? So time series is one use case that these kind of neural networks are good at, right? Long short-term memory is a popular neural network that is RNN, that can handle long sequences. This is a typo. It can handle very long sequences, and this is where my large language model started coming up, right? This you can read about this long short-term memory. This is a neural network that is categorized within RNN neural network, right? And then there is something called convolution neural network, where the data is not serial. Like let's say you have an image, right? The image is not serial. It is a one single image that goes inside the neural network, all right? And you try to find a pattern in that particular image. You have something called as filtering layer. The input layer, or the input goes in through input that filter layer, and it tries to find out that filter, whether that filter matches to that input layer or not. So let's say this was your whole image, right? And you have one filter which is 3 by 3, right? And this image is, let's say, 712 cross 1080, right? So this 3 by 3 matrix will go in each cell 3 at a time, and it will take one step at a time and try to find whether this filter, when I say this filter, is particularly trying to match a pattern. This pattern can be, let's say, this is a 3 by 3 matrix. It is filled here and it is filled here. That's it, right? So it is trying to find that pattern, that filter that that you have created, trying to find that pattern in your image. And if it is able to find the pattern, that is the input, that is the observation that it pass forward, and when it pass it over all over the image, and there can be n number of filters that you can apply on an image. That's why when I say it is computationally heavy, because it is doing all this calculation. One iteration, one metric over that image at a given location ends up in a calculation, and then it moves to a next step. And there can be millions of such steps within one single data information. In this case, data information is one single image, right? So these kind of neural networks are good at pattern recognition, right? You have face recognition that comes up, image or video recognition, right? Or other vision related tasks that we have, because in again vision, you are processing that image, right? And that needs to be done in within less than a second. So again, the better compute you have, the better calculations will happen. The faster calculation will happen, and the faster outcome will be available, right? So this is how you train different neural network, different use cases. Depending upon the use cases, this hidden layer is configured, and you get the output, right? This is very brief, very broad level understanding of different type of neural network. Again, each one of them can be a separate individual topic which can be discussed in detail, but that's not the agenda of our course. Hence, I am not going in detail, but yes, you are free. I just gave you a brief overview. If you want to go deeper, definitely you are free. You can go and explore how this things works internally in details, right? Um, shall I proceed to the next one? Are you guys with me?
Yeah, makes sense.
Okay, great. So you guys understand majority of us are comfortable with Python, and some of us are also comfortable with data or data science or machine learning as well. So there is something called data pre-processing that we mentioned earlier, right? There is something called feature engineering, or let's say if I club this all together, there is something called EDA, where this EDA is exploratory data analysis, where you try to explore your data, how your data pattern is, if there is any correlation across your data columns or data points, or if in case there is some missing value, how do you impute those missing value? When impute means you replace those missing value in your data, how you engineer everything is done in your input, when you process your input and pass it to the input layer, right? So there are some frameworks, some libraries which helps you do it faster, which can enable you to actually do all those stuff faster. Like for this particular scenario, we have something called pandas. This is a framework. How many of you understand all these ADA process, pandas, NumPy, Seaborn, Matplotlib? If they, is there
Yeah.
anyone who does not understand this? Maybe you guys can respond if you. Okay, I'll take the silence as everybody of us understand uh, all these basic frameworks, right? I'll take it from here. So similar to pandas that we had for a specific task for data manipulation, data exploration, NumPy for numerical operations within my data, Matplotlib and Seaborn for visualization of my data in different scenario. We plot. There is something called Plotly and all that. Just like those framework, we have frameworks in neural network itself. There is one framework called TensorFlow, right? There is another framework which is Keras. Keras is built over TensorFlow, so it make it more easier or at a much higher level to use those TensorFlow. There is something also called PyTorch, right? So these are some of the frameworks, just like we have Pandas, NumPy, and all, which enable you to configure or play around with your data. Similar to that, the TensorFlow, Keras, PyTorch, these are some of the framework or some of the libraries, all open source, which you can use to configure or build your neural network, right? It enables you that faster debugging, faster creation, faster layer. How many neurons you are in your you want in your hidden layer? How many hidden layers you want? What is the dimension of your hidden layer? What is going to be your input size? What is going to be your output size? What is going to be your loss function? What is going to be your activation function? Everything you can configure easily through these libraries that are available. It is just one liner of code and you will be able to configure, right? And if I go,
When you go to the practical, can we have a demo of how to build this tensor using tensor and keras, at least some neural networks examples?
okay, yes,
Just give examples like for every model, CNN, RNN, or maybe whatever is the maybe the neural networks using some
mhm,
of these packages. Can we? That would be
yes,
good for us to understand how it is
yeah,
configured.
definitely. Yes, I completely agree to that if you would have something on that part. But and I'll try to accommodate in that in my next session since you have asked. But the idea, and then why I am not included in this particular in the next session, we will be having some hands-on notebook as well. The reason why I do not have in this particular session is because this was a brief of like brief building up of what we are going to consume next. Otherwise, each topic that we are discussing right now can be a lengthy 2-3 hours of topic, which can be detailed discussion of how internal things are working, right? It can be overwhelming for some of us, but it was just to build up. This is something that goes inside. You might need not to know everything nitty-gritty inside what is happening at this point of time. So maybe once you start getting up into the things you grab, right now the agenda is we learn a new skill. If you start learning this might take us some time. But let's say first you learn the application and then you again back propagate and you understand how nitty gritty and things are working. If we go into nitty gritty, this course itself can be in months, right? You understood why we are trying to flow this conversation so that we have a brief understanding or a base ready of how things are flowing, and then we build up over and above this.
Yeah, it's fine, it's fine. No problem.
Yeah, great. Okay, so just like I mentioned, TensorFlow, Keras, PyTorch, these are some of the framework which helps you to build those neural network within like couple of minutes. You can build a neural network. That's not a rocket science. It's just how you use those uh, hidden layer and how you optimize that makes a difference, right? So what this framework was, this TensorFlow was created by Google, open sourced back in around 2015-16, and since then neural network has been a good hit, right? Then what is a tensor actually? Tensor is a like multi-dimensional array which can hold the data points, the data value, which stores the data that we have inside it. It can be one-dimensional, which we call as scalar, like 1, 2, 3. These are individual values. Again, as we increase the dimension, the value that it can hold, it can be of different scale. Like a vector, it can be like this, a single list of numbers, you can call it, and it can hold like the data points that you have. When we go to a next dimension, which is my 3 dimension or like the 2 dimension, we have the data horizontally as well as vertically. So you can take it as a metric that we have, where you have A, B, C, D, like these kind of value. The values can be organized in a metric. And then when we go to 3D, this again become a individual unit, and this can be again multiple metrics within a matrix. So it's like when you have one data point uh, you can put in a list. That list can be part of a metric, and metric can part of a bigger 3-dimensional metric. It is and this is just 3-dimensional. Imagine when we will be working with vectors, the embeddings, we will be having n-dimensional, which is beyond human imagination. There can be thousands of dimensions. Currently, this is just 3-dimension, right? So this is what a tensor is. It stores that information within itself, and which can be taken further for compute, right? So let's say in this particular scenario, if you see, this is my one tensor, this is my one tensor, this is my one tensor, which stores that data information, right? And when this information, let's say we have these data points, and I'm doing some operation on these two data point, right? A on B, I'm doing a sum of these data points, right? And for B and C, I'm doing a subtraction, right? This is some calculation that I'm trying to do. Obviously, this calculation may not be this easier. There can be like complex calculation that are happening inside within that neural network. But for the simplicity, just for the concept purpose, let's take it that there is this simple calculation that is happening, and once we have the outcome, we are doing the multiplication of these, right? So this network that is built up, this is called computational graph of my neural network. How the operation is flowing within my neural network, right? That is called my computational graph. And there is an important term called DAG, and that is directed acyclic graph. Uh, so as the name itself says, this is acyclic. So it cannot never happen that once you achieve the node, this node is directing back to one of the starting node. It can never happen. It is acyclic. It cannot never make a cycle, or it can never make a loop. The calculation flows forward, right? And it is directed in the sense that it always have a direction, whether what particular tensor, how it is connected to other one, you will have that calculation. It will have some direction whether what kind of calculation will be included. So it is a directed acyclic graph architecture of my neural network, right? Are we guys on the same page? Are you guys following me? Yes. Okay, we only have Shravan that is following. Okay, we have Kalpana
See,
also.
this one,
We are
this DAG one, which maybe TensorFlow used for that, you are saying?
Yes, TensorFlow is helping you build those neural networks, how you define those layers, how you
This
tell
DAG also, you are saying part of neural network only?
TensorFlow is helping you build that neural network. TensorFlow is not a neural network. It is helping you
No, no,
to
no. I'm
add a
asking this
layer.
DAG one.
DAG1 is like a cyclic representation of how your information is flowing. So it is just a concept, right? It is not something. So let's say you have a millions of nodes in your neural network. You might not want to go through each and every neuron and see how the information is flowing inside that. Yes, on a broader level, you will understand that what was my input, what is the calculation that is happening, how the base, how the weights and biases are changing, and how the information is flowing from one layer to another layer, right? If you have one neuron, you have two neuron, you can maybe want to look, okay, how things are flowing, but this is just for understanding how information is flowing. The purpose of this DAG is how information is flowing like from one step to another step, right? And then there is something called eager execution or graph mode, where eager execution is where you do not build this overall architecture and you start executing the node. So how many of you, or I'm sure if you all are comfortable with Python, you know how the compiler works, right? If you create a function, the function is executed only when the function is called, not in the starting. Initially, it is just there in your environment available to be used. Later, when you call that function with the proper arguments, then only it is executed. So it is this similar way that in the graph mode, initially the graph is built, and once you call it, then only it is executed. And in the eager execution, definitely it is completely opposite, that it is executed instantly. So if since it is executed instantly, so each node is executed instantly when this is built. So it is obviously time consuming. It is intensive. This is not so optimized. This is not that good in compared to graph mode in terms of performance. But it can help you debug when you are moving step by step. It can help you debug if in case you encounter any sort of error, right? There is portability. If you are having a graph mode, once you create a function, you can call that function. You can easily scale that function, right? So that is always a trade-off between if you want to make your neural network more portable, or if you want to make it more debug friendly, right? So initially, you maybe start with debugging, and once you have all things in place, then you put it in the graph mode, right? How the compilation is flowing. So this is a basic overview of how this neural network gets executed or get compiled when the information is flowing from input to the output layer, right? Keras is nothing but a framework that is from TensorFlow. It is even giving you a broader scope of how you use those neural network, or how you build those neural network. This is a high level API that can help you do all these tasks, right? Again, high level API, low level API, these are again something that can be taken for discussion and for a long discussion, which is not the agenda or the which is not the part of the curriculum. So I'll restrict myself there, right? Uh, so you guys understood how the TensorFlow is being used, how the information is flowing, what are computational graph, what is graph mode, execution mode. These are some of the basic terminologies. When you are building your graph, you should be you building a neural network. This is something that help you get a better understanding of how things are flowing, how things are working internally, right? rest, once you start executing it, actually, when you build a neural network, you will definitely get to know much more things and much more details, right? And I think we are already hitting the time. Uh, okay, so maybe I'll take it up from here tomorrow. We have a session tomorrow as well. And if you have any doubts, we can take up the doubts now. And is it okay if we extend for 2-3 minutes by the time we are discussing the doubts?
Yeah, yeah, Ankit.
Okay.
Ankit, but like I think we are generally discussing fundamentals.
Yeah.
Just my doubt, are we means we should not be in a hurry for main topics, is it right?
Okay, so if I completely agree. We should be first building the base. So if we start, so this is something that when you are building the generative AI or large language model sort of curriculum, this is a prerequisite. You
I
understand the
agree.
neural networks, you understand some of the internal working, and then you will be better able to grasp how the large language model is working or how it is built, right? So this was just a brief overview of how things are working, so that if some of us are not aware of those internal things, you guys are able to grab things which we will be discussing later.
No, no, Ankit, just my point is that because if we are making more time here, might be we are multimodal, lang chain, lang graph, might be we will
Mhm.
be faster to because they are the fixed classes as per my understanding.
Yes, yes.
Then might be somewhere we will
Okay.
not
Nice.
go.
So, I'll beg to differ from you on this. Lang chain, lang graph, agent, everything. These are all implementation once your large language model is ready, or you understand ठीक है, how things are working internally, or you want to use it, right? You are on the consumption side of your large language model, right? The things that we are discussing in here, these are on the building side, or how that large language model is built, right? But what I am told, and what my understanding of the curriculum of this particular course is, that we are on the consumption side of how things can be consumed in different scenario, how to use them actually, how to consume them actually, so that you can leverage the use case to upskill yourself, right? Just let me
Yes,
know
yes.
if we do not align on this.
No, no. Means my point is like generative is we are doing a feature generation.
Mhm.
So here generally there is a few points is related to feature generation. So all
I'm
those
sorry,
things.
your voice is very low. Can you please be a little louder?
Hello, am I audible?
Yeah. Yes.
I think yeah. So what I'm saying, yeah, generative AI and yeah, this is a base, but my
Mhm.
point, this base on what is the scope of this. Just my request. I think we are not missing further topic in future because I saw in
Mhm.
past training sometimes
Mhm.
we are in a hurry in last and might be there is a very useful things is there.
Mhm. Mhm.
That's my request.
No, don't worry. We will not be in a hurry of finishing up things. We will be discussing the use cases. Currently, what we have discussed in today's class, and probably what we will be discussing some of the topics in tomorrow's class, since we are not able to cover it today, and some other topics. They are all just basics that are I can definitely call them as a prerequisite, which is something that we are taking, let's say I'm discussing, so that everybody is on the same page. It's not a bouncer for someone who is not having so much of technical understanding of internals, right? So that they have a broader level understanding. If we want to go ahead with the deeper understanding, then I'm sure you will also agree that it will not finish up in even in, let's say, 3-4 months if we are doing a weekly sessions. It
No,
will
no,
need time, it will need all that. But yes, I'll definitely see if I can include that how the neural network is built, how you can see that what is, how many layers we are putting in the input, how many hidden layers that we are processing, what is the activation functions we are using. I'll definitely see if I can integrate that in my tomorrow's discussion. Yeah.
yeah, but in LLM, I think there is a nothing we will do. Is it right?
Sorry,
So,
in LLM.
means LLM just as per my understanding, this is already tuned model. Just we need to consume it. In RAG case, just we need to do our private knowledge and get based on that. This we need to generate the data.
Okay, so it's not that straightforward, actually.
Yeah. I mean, not straightforward. Just I'm summarizing. So my where I joined this course, I think we are deep dive in this direction.
Okay, so maybe we can discuss it later. Just give me 2 minutes so that we can take up doubts if someone else have, and then we can continue this, right?
Sure.
Yeah. Do we have any more doubts from today's session? No? Okay, thanks. Thanks, Samshir. Thanks, Aswat. I hope you are able to better utilize your weekend. And we have a lot coming tomorrow as well. So yeah, all the best. I would really request all of you to just revise through what we have discussed, some of the topic, just browse through internet, browse through YouTube, and see uh, if we are able to get some better understanding, more broader understanding, because that will help us in later sessions also. Yeah.
Yeah.
Okay, great. All the best for the learning.
Thank you.
Yeah.
Thank you.
Yeah. Thank you.
Thanks, Ankit.
Yeah. Thanks. Thank you.
Shall we discuss?
Yes, we can discuss.
So Ankit, that's as per my knowledge, like we have it's a very vast, so like RAG implementation, RLM implementation, multimodal things is there. And after
Mm.
this deployment will be also there, infra level,
Yeah.
sizing all those.
Mm-hmm.
So I'm already, I told you I'm an architect position.
Mm-hmm.
I know NNN, RNN, we are using this. This is a basic. If we will deep dive, I think we will cut short those topic in detail. That's why I'm requesting. Are we not cut short in those things? That's fine, because we sooner we need to implement in our company. Those things. That's why
Yes.
I'm talking this.
Okay, so just correct
RAG
me if I'm wrong. Yeah, please go ahead.
in our company, RAG we are using because we are
Mm-hmm.
a SaaS-based company,
Okay.
and we are giving a personalized generative data based on the tenant,
Mm-hmm.
because we are providing a searching mechanism and all those things in
Okay.
our system. But I want to do a deep dive because nowadays Gen AI is going to the means
Yes. Okay, so just one thing, if you can answer. Did you have you gone through the curriculum for this course when you enrolled?
yes.
Yes.
Yeah.
And did you find that it was deeper diving into how LLM is built, like in the neural networks, the algorithms backend in there, or
No,
was it on the use case side?
use case side.
On the use
And
case
my
side.
intention is also use case side, because my worry is not nowadays so many tools is there. Windsor,
Mm-hmm.
I'll get a code easy.
Mm-hmm.
Creativity is here. Find the use case and how to go in a direction.
Okay.
That's matter.
Okay, nice. So
So
what I can do from my end is I can include those how the neural network is built, how you configure those internal layers, how you configure those activation function, loss functions, how all these things happens. I can we can walk through this all together. But if you want for like all of us to spend maybe a couple of sessions around it, so I don't think we are aligned in terms of agenda, because
no,
based on the
no. I'm not
curriculum, it
worried
is
about
more on the use case
Ankit.
side. Yeah.
I'm not worried about the neural network function
Mm-hmm.
at all. What today is
Okay.
going, I know that. Might be I'm not hands on, but basic is required. TensorFlow go beyond two-dimensional data is a good library. PyTorch is booming a lot.
Mm-hmm.
That we know. But when Gen AI, this is also is not a next level thing. Gen AI made on top of this. I agree.
Mm-hmm. Mm-hmm.
So that area, that fundamental of Gen AI, might be next topic is a Gen AI evolution. Something is there. I'm not
Mm-hmm.
remember. So those area I want to do a more use cases. So my mind will work in this direction, and company use cases I can fit those use cases and bring my company product to the market.
Mm-hmm.
That's my expectation from this course.
Yes, we will definitely come up to that. Okay, so
Because
maybe
my,
I'm
my, my point,
understanding it wrong.
yeah,
Yeah,
Ankit, yeah, my point is there.
yeah.
If we will go in this deep dive, I
Uh,
think those things we are not going to
no,
use.
no, no,
So that's why
don't
I'm
worry
saying,
about that. No, no, don't worry about that. We will be discussing all those things in detail. All the use cases that we have, we will be discussing all of them in detail. And it was just so that you have understanding of how that neural network is working, right? Internally, those convolution network or RNN neural network, right? But not everybody has that understanding. So this purpose of this today's overview was just so that everybody understand how we are evolving from machine learning to the neural network and how the transformers would be accommodating this neural network architecture on which the next LLM model is built, right? So that everybody are able to grasp that stuff. So if let's say
yeah,
there is someone who do not understand and I start directly with the transformers, it would be difficult for them to digest, right? So let's
yeah, makes sense. So transformer, we need to go in depth. I agree, but
mm,
you are planning to do will code walkthrough for those things, right? Need
no,
to.
no, no. So this was just like pre base building session, you can say, right? So that everybody are on the same page. Some of us, like you saw today, some of them were not through our like
No, no,
machine learning
I'm
background.
अंकित, I'm 100% agree. मतलब क्या
Yeah.
कहते हैं ना हम लोग कि मैं मुझे कोई दिक्कत नहीं है.
Mhm.
Sorry, I'm
Yeah.
speaking.
No, no, that's okay.
So I
No,
don't
no,
have
that's
any
completely
problem.
okay. Yeah.
So I don't have a problem. But my point, whatever main agenda, because I it's a crisp course. I know I need to do more work on top of this. But what
Mm-hmm.
crisp is there, I will get a very fair understanding in our system,
Mm-hmm.
and
Yeah,
that I
we
can
will be.
immediately after this course onboard it.
Nah, yes, don't worry about that. We will be definitely going through the use cases and everything in detail. Don't worry about that. I assure you that. Okay.
Because I already saw there is a agentic is a separate course also there. Is it right? So this
Mm-hmm.
I feel generative AI is a base on top of this agentic I will go. So I bought it both the courses, but I think
Mm-hmm.
entire agentic is not covering this. Is it right? That's a different thing here.
Yes, so we'll be touching up on how the agents are made, how you can use or how you can leverage them, and know your use cases, right? If you go in the full time like agentic, you will be definitely going deeper into the complexity and uh, high level of agentic thing as well.
Yeah,
Okay.
we are planning to go workflow management. To be frank. So
That workflow management goes inside NA10, right?
N10 is not personalized now. It's a very generic. Problem is that
So
SaaS based.
yeah, so we'll be touching up all the topics that are there in the curriculum. If there is anything and something you want on the ad hoc basis, we can definitely take it up. But that is something that will decide based on the time, how much time we
Uh,
are
I,
left
I,
with.
I 100% agree. I don't deny. Even I deep dive the curriculum. I got it. If that much is also whatever next
Yeah.
session onwards, I'll got it.
Hmm.
But can we get your number if something because we are
Hmm.
evolving our
Yeah.
company in Gen
Yeah.
side. So sometime we need our help. So can I call you on something? I'm not
Uh,
sure.
okay, I'll need to check with the management if I can share my contact details. But definitely you can reach out to me over the LinkedIn. Uh,
Can you give LinkedIn things to me?
yeah, sure. Just allow me a moment. Yeah, I've shared it in the chat. Okay.
Yeah, yeah.
Okay. So I think we are good for today. We'll catch up tomorrow.
No, I'm
We'll
good.
be,
I'm very good. And your slides is very crisp. I couldn't see that much crisp slides.
yeah, thank you.
To be frank, that's a
Just
good
preparing
thing.
so that everyone are able to grasp thing, even if they have expertise or even if they are beginners. So just trying to work around that. So just
Yeah,
maybe
I
sometimes
saw
bear
that.
with us so that like when I'm explaining something to someone who has not that grade of understanding or who is starting with, maybe you are already aware of this, but things might be overwhelming for them.
I'm not that much great in this. I'm telling you. Just past 2 months, I'm learning machine learning and
That's
pandas and
fine.
those things. I know that. So
Mm. Okay, yeah,
because
that's good.
as an architect, Ankit, you can understand. I need to do
Yeah,
the cost and all these things.
I understand.
I'll
No
connect with
worries.
your LinkedIn and we can
Yeah,
chit chat more.
sure,
So, are
sure.
you planning to share these slides also?
Yes, I'll be sharing those slides. Don't worry about that.
Okay.
Yeah.
Thanks.
Okay.
And thanks for
Okay.
wonderful.
Yeah. Thanks. We'll see you tomorrow. Okay.
Sure.
Yeah. Thank you. Bye bye.